We are in the last chapter of pre-calculus, polynomials and rational function. So before we go to polynomial, we're going to talk about the power function. Power function, the standard form for the power function is f of x equal to k multiplied by x to the power of p. K and p, both of them are constant. They can be any numbers. For example, f of x equal to 5 x to the power 9. G of x equal to 100 x to the power negative 50. H of x equal to 1/5 x to the power of 1/2. So as long as there is an exponent above the x, this will be a power function. So in this chapter, we're going to learn how the power function look like and what are the properties. The first type of exercise that we're going to see, I give you guys a function like y equal to 4 over radical 16x. And the question is this a power function? Is this yes or no to the power function? If it's yes, make it to a standard form, which is a constant multiplied by x to the power of p. In your homework, they might ask you what is k and what is p. So in order to find k and p, we need to do little algebra. So I'm going to break it down. I'm going to say 4 radical 16 multiplied by radical x. So here's multiplication. This equal to radical 16 is 4. So this 2 will cancel. We have 1 over radical x. So far, this doesn't look like a power function. But if instead of radical x, we made x to the power 1/2, and if I bring it up, it will be x to the power negative 1/2. So p will be negative 1/2, and k will be 1, because here is 1. So it is yes. Let's have another example. Y equal to 3 parenthesis 2 over 5 radical 7x to the power of 4. So in this example, I'm telling you guys that this is a power function. You need to tell me what is k and what is the value of p. So let's start. This is a multiplication. This 4 is above this parenthesis. That means I can apply 4 for this one, 4 for this, and 4 for the radical. I'm going to have 3 multiply 2 to the power of 4, 5 to the power of 4, multiply radical 7x to the power of 4. So equal to, we have 3 multiply to the power of 4. Instead of to the power of 4, I'm going to just put 16. 5 to the power of 4 is 625. And this gives me 49x squared. this is, so 7x to power 1/2, this to the power of 4, 4 by 1/2 give us 7x squared, which is 49x squared. So we're almost done. We got the very ugly number, but we have 3 multiplied by 16 divided by 625 multiplied by 49 multiplied by x to the power -2. So -2 will be our p, and this number will be our k. So you definitely need to review all the exponent property. All right, let's now learn how they look like. So power function. So y equal to k multiplied by x to the power of p. For y equal to mx plus b, the first thing we learn, we know is a line. The line might be have a positive or negative exponent, negative slope, or vertical or horizontal. So but the graph of mx plus b is a line, and graph of quadratic we learn, which is a parabola, concave up or concave down. For cubic we learn is a chair. It look like this. But for the power function, or one more thing for exponents, like e to power of x, we learn is exponential like that, or sometimes is decaying if x is negative. So this was a review, but for power function, we don't have a unique graph. For example, I'm going to say k equal to 1, and for p equal to 2, we will get y equal to x squared. If p equal to 3, we're going to have y equal to x cubed. When p equal to 4, we're going to have y equal to x to the power of 4. So definitely for if p equal to -2, we're going to get y equal to x to the power -2. So definitely we can see we have a parabola, we have a chair, we might have a w, we have a rational function like this. So we are dealing with different type of graphs. So in this section of the chapter, you need to memorize some of the graph. So let's do this. So we have y equal to kx to the power of p. So we group p. If p is 2, 4, 6, and 8, all the positive even number, so we're going to have x squared, x to the power of 4, x to the power of 6, x to the power of 8. If we graph them, all of them, like x squared is like this, x to the power of 4 might be little wavy like that, but all of them, for the long term, for negative infinity to positive infinity, if you look at the long run behavior, they are behaving the same way. So all of them, for example, x squared goes up, also x to the power of 8, it will go up as well. So on the infinity, all of them will be behaving same. But at the beginning, from here, no, they will not going to be exact same. So we learn all the positive even number. If we have odd number, like p equal to 3, 5, 7, 9, 11, 13, like x to the power 3, x to the power 5, if you graph them, all of them will be, looks like a chair. like x cubed. It will be like this. X to the power of 5, it might be something like that, but again, we are dealing with big number from long term, from negative infinity, from here or there, they will acting same. So far we talked about all the even and odd, positive. So y equal to. So what about if, so we deal with 2, 3, 4, 5. So if this is a number line, this is 0, 1, positive infinity. So now let's see if it's 1, what do we get? If p equal to 1, positive 1, we're going to get y equal to x. So we're going to get the line. If p equal to 0, we're going to get y equal to x to the power 0, which is 1. We're going to get horizontal line. So again, for this chapter, we're only analyzing on the long run. So for 1 we know, from 0 we know. From 2, 4, 6 we know is like a U. For 3, 5, 7 we know is a chair. From -1, -3, -5, so all the odd negative, like x to the power -1, x to the power -3, x to the power -5. If we graph them, it will be something like this. So that's a graph of x to the power like a -15. It will be something like this, because it's negative and is odd. If we have x square, so negative even number like x to the power -2, x to the power -4, x to the power -6, this will be a rational like that. You have a calculator, you definitely can use the calculator if I give you multiple choice to see which one is graph of like x to the power -6, but I would recommend to just memorize it. If you graph it, you should get something like that. All right, we talked about all the numbers, not like fractions. Like what about x to the power 1/2, x to the power 1/3, x to the power 1/4. So x to the power 1/2, it will be radical x. So the graph of radical x will be like this. X to the power 1/4, fourth root of x will be similar. X to the power 1/3 will be cube root of x will be this shape. It would be great to have all those graphs in your note sheet. All right, let's have some exercises. I give you a power function like y equal to x to the power -10. I give you 2, and y equal to negative x to the power of 10. They're asking us what is the behavior, so this is y1 and that's y2, as x approaches 0. That means what is the limit of x to the power -10, x approaches 0, and what is the limit of negative x to the power 10 when x approaches 0. So in order to answer this, we need to graph it. X to the power of -10, so we're dealing with even negative number. So the graph will be something like that. They should say from positive. So from positive direction means we're going to go from this direction to 0. So when you're closing to the 0, the value of y will go all the way to positive infinity. It goes to positive infinity. Now let's graph this one. X to the power of 10, this guy, x to the power of 10 is even positive number, so it will look like a u, like this, but it's negative, so we're going to flip it. It will be like this. So this graph of x to power, negative x to the power of 10. When x goes to 0, the value of y is 0 as well. All right, I'm going to